3.6 meter long ladder rests against a vertical wall BC, making an angle of 70 degrees with the horizontal ground. The ladder is rotated in a vertical plane about E to rest against the wall AD, reaching a point 2.6 meters above the ground. Show, in use of trigonometry, determine the angle through which the ladder was rotated. So that's this angle just here. So it would be nice to know this angle. And we know that the ladder is 3.6. So let's call this alpha. We know the opposite and the hypotenuse. So sine alpha is equal to 2.6 over 3.6. So that means that alpha is, let's just bring in the calculator, and we want to be on main and we're in degrees decimal, that's fine. So I want the inverse sine of 2.6 over 3.6, and so that gives me 46.24 degrees. So the angle of rotation, let's call that theta. So theta is going to be 180, take away the 70 we had, take away 46.24. So 180, take away 70, take away the last answer, gives us 63.76 degrees. Correct 2 decimal places. We won't ask for a particular number of decimal places, so that will do nicely. We now want the distance AB. Well, that's going to be this length added to this length here. So if we think about this, that's the adjacent. So EB is going to be 3.6 times the cosine of 70 degrees. So we can work that one out, do that in a second. Now AE, we could use trig or we could use Pythagoras for this one. So let's do the square root of 3.6 squared take away 2.6 squared. So 3.6 times cos 70 gives us 1.23, and so on. And then we've got the square root of 3.6 squared take away 2.6 squared, and that's 2.48, and so on. And so AB is just going to be the sum of those. So it will be this one added to our last answer. So 3.72, and it's in meters to 2 decimal places. We now want the distance DC. So that's this distance just here. Now there's lots of ways we could do this, but since we know this is 3.6, this is 3.6, and we know this angle down here, we could use the cosine rule. So DC squared will be 3.6 squared plus 3.6 squared, take away 2 times 3.6 times 3.6 times the cosine of whatever it was, 63.76, and so on. And so we can work out what DC is, and we could have used an E activity for that. So let's just go down here. So we've got 3.6 squared, add 3.6 squared, take away 2 times 3.6 times 3.6 times the cosine of, let's just go and grab it from up here so we can copy it and then just paste it in there. And that gives me 14.46. So it's going to be the square root of that, isn't it? Because remember, that's DC squared, 14.46, and so on. And so what we now want is the square root of the last answer. And so that is 3.80 meters, correct to 2 decimal places. A thin metal plate in the shape of an equilateral triangle has an area of 330 centimeters. I'm thinking that should be squared. Determine the side length of the triangle. So let's suppose this is our triangle. Since it's equilateral, we know that this is 60 degrees. We're trying to find the side length. We know that the formula is a half AB sine C. So half of x squared times the sine of 60 degrees has to be equal to 330. Well, we can just solve that on the calculator. So action, advanced, solve. So 0.5 x squared times the sine of 60, which I actually do know the sine of 60, so I could have just used my exact value, but I didn't. So equals 330, and it's got to be the positive one, so 27.61 centimeters, correct to 2 decimal places.